Hey everyone. So thank you all for joining us at React Advanced London. Hope you all are having a great time enjoying such enlightening and insightful talks. So in this session, I would like to discuss how do we think UIs in React and how like state machines can help us like build more performant and like more easy to maintain and bug-free ones in the future. So before diving in, little bit about me. So for the ones who don't know me, hey, I'm Nikhil. I'm a software engineer at Postman. I mostly handle stuff around Postman on the web and Postman's just a platform. I love to also talk about design systems and performance in general. So here are my Twitter and GitHub links. I'll be glad to connect and have a chat. So moving forward, let's start with the thought that while building more complex problems, we have started to develop more complex solutions with time to make the lives of users easier, right? So it's a known fact that right now, like back at the old times, we did not have those amount of complex problems to solve, right? And neither did we have the right tools and like the right set of things to make our UIs the more richer and like more performant like we have in like we have right now. And that's basically the reason like why we mostly had some static websites and stuff like that, where like we did not need any of the inputs from users. We did not expect users to interact much with our websites. Rather than what we have right now is more of web apps where there is a ton of user interaction, right? So as the time has progressed, developers and designers had started to think more upon things around user experience, and so did the solutions. And like as things have become more complex, and like as we are trying to solve more complex problems, the solutions or the UI we are now building start to become more and more dense and more complex because now they have a ton of more things to offer to the user, right? So with such a rich UI, the users like always get a chance to surprise us developers, right? By using our apps in like a ton of different ways where we might not have imagined them using it this way, or like we might not have accounted that particular way for. So a user might use your app in a whole different ways, which you might have not thought of. And that actually highlights the need of us now planning our UIs better. So like now is the real need for us that we need to plan our UIs. And I would rather say that it's like not only up to the users, it's also us that we mostly follow the plan of implementation rather than the plan of maintenance, right? So we are mostly into this concept of that, hey, I have the UI to build. Let me just go and define what all things do I need to have, what are my effects that I need to run, what are the logic that I need to run on an on change on an input and stuff like that. So like we are more into nitty-gritties of implementation rather than taking a step back and thinking more upon how we can start with maintenance and how we can start planning our UIs better so that they are more performant and more maintainable in the future. All right, with that being said, let's try to see things in action by considering a very simple example. So as you see, here's this small code snippet of a basic login form. And what this does is like you have two text inputs, a user ID, a password, and then there's a button at the end where you click on it and it either logs you in or it just shows you an error. If you would ask me that how we are right now thinking in UIs, what we would start diving upon is, okay, there are two states. We have username and password, done and done. Then we think of, okay, there is some async part that we have to do. So let's create a function on top of that to do that async stuff, which in this case is to click on a button and send that data so that we are able to log in. And thirdly, we just think of, okay, there is some UI that needs to be rendered. So, okay, let me just render two text boxes, one button, and we are done. And you might be thinking that, hey, man, why would we need this topic in the first place? This is so much obvious to do, right? And that is where I would like say that, hey, this is a very minimal thing, right? What if I want to show a sort of a success or an error message in the future? So like right now, we just have a text input, a pass for a username, password, and then a button. And I just click on it and that's it. So what if like I have to show such type of messages to the user? All right, now you might be thinking that, okay, now work has started to develop on us. And now we see that, okay, two more states, not an issue. And then inside our asynchronous task, we handle how we toggle these states. So as you see in the submit form function, if everything works out well for our async data, we set this is success to true. And if not, we then set is error to true. And inside our UI's part, we then do, okay, if there's a success, okay, we have logged in successfully, and else we just show a paragraph that, okay, there's some error. All right, let's try to think more deeper in terms of, okay, what if I want to disable a button? And then you would say that, all right, another stage, some more work to do on submit form. And then I have to disable this button on this loading state based on this loading Boolean flag. And now that's this. And now I think you are able to realize what I'm going to go to, right? So first of all, the problems with this type of an approach is, firstly, this is difficult to maintain. These are just 3 states right now, but as this form starts to become more complex and like more mature, there are going to be ton of more states, and it's going to be really difficult to handle them in the future since this length of code starts to increase so much. Secondly, there is a concept called state explosion, right? So right now I just have mainly 3 states to have my UI ready. But if you see on a broader picture, we have 2 to the power 3, that's 8 permutations and combinations in which our states can exist. So like there are basically 8 ways where our UI might exist if you see mathematically. Honestly, you might not basically need those states anywhere in the future, or like those might not have to be handled, but hey, your user can access it or like reach to that state in like any other form. So you have to account on that. And thirdly and most importantly, this is really difficult to visualize, right? Because your app has a soul, which is the logic of your app, where you're doing that logical thinking part of your app. And with that logic being spread like sugar spread around like different parts of your app, it's like really difficult to make sense out of this code if I'm a new developer and I start to work on this code. So it's like very difficult to understand. And basically, that's what I call Horcrux code. So if there are Harry Potter fans in the audience, I think you all know that. So like this Horcrux, so like this is a Horcrux where you had, so like these witches had a way of creating, so like they could just keep the part of their soul inside one place and a part of that soul in another. So that's what's happening inside our code base. So the soul of our app or soul of our code, that is our logic, is being spread across multiple places. And like this is why it's very difficult to visualize that code. And this is a very small example, as you might have seen. We have a lot more complexity in our UIs and a lot more features to offer. And it's just like not just more about a login form, but it's much more than that, as our UIs have started to become tremendously complex and big. So now we know that, right, that planning is really important. And with planning, you can like make your code maintainable, you can catch bugs easily, you can make your code more visualizable, and that helps you. But what are we doing with planning, right? We are mostly following the concept of implementation sourced planning, right? And not maintainability sourced planning. So with our example previously that we showed, we are mostly thinking about, okay, what is there on our effects, what are the props, what are the states, and whatnot. And that actually brings us to a conclusion that what can be a better way, right? What can be a better way of planning our UIs rather than planning implementation? And now you might be able to see that since we have a lot of states and there can be a lot of permutations and combinations of those states in the future, there has to be a way, or like there has to be some sort of a system where we can be saved from this multiple if-else statements to handle what to do when this state is there and this state is not there. There might be a system where we can just check and we can just orchestrate our states and transitions between those states in a better way. And obviously you guessed it right. So there comes finite state machines to our rescue. So if I had to put this in a very simpler way, what finite state machines have to offer is basically you have an initial state or initial condition or an initial situation of your UI, which it might be in. And then you might perform some action with that state. And like if that state receives an action, it goes on to a next state. And at every point of time, each state knows based on an action that what is going to be the next state that your UI or your code is going to go through. And that's what these 3 words mean, right? You have a finite number of states. You have a state, obviously, which is a condition or the situation your UI is in. And basically there's a machine which is orchestrating that state and how those states transition based on actions. So that is mostly the whole point of a finite state machine. All right, so that being said, let's try to start thinking about how we can think in state machines. with that. All right. So with that example in mind, we are mostly going to see that, okay, there are basically four types with which a UI can exist, right? Either it can be idle, or I might click the button to make my UI go in a loading state that, okay, I'm being logged in. And if I log in successfully, I go to an is success state, or I go to an is error state. And that what makes our transitions defined, right? We define that, okay, what is the current state, and based on that, what are the transitions that that state can go to, and like what's that next state. And basically, that being said, you have a state, you have an action. For example, if I'm on an idle state, I do an action called submit form, and then I go to a state called is loading. And like that's how you like visualize things and how you create a mental model of state machines in your mind. So if you see a mapping between your visual and code, it's just basically on the right side that you see two simple objects where a states object just defines what are these circles on the left, which are the states that you have. And this transitions object just lets you know that, okay, if I am on a state, let's say states.idle, and I perform an action called submit form, I go to a state called states.loading. So that's make your UI more predictable. And like, there's this logic all at one place. And obviously, like since we have this brain ready, we have to tell this brain how to communicate between its other states, right? So this is a function called transition. And what it does is like basically it knows that, okay, what's the current state, what's the action, and based on this, where do I have to go to the next state? And this brain and the body being set of this machine, you just have a simple function just down below, which is update form state, where you just do nothing but just let transition tell you that, okay, what's the next state? And I just set my state based on that. All right, so enough being said. I think you're bored of all these theories. So let's try to go inside what is the real action. All right, so there's the simple example of this form, right? And now this is being just implemented with that implementation detail approach that we had in mind, right? So let me bring in that boilerplate code, right? I already have this written here. So let me just take this, I copy this inside my function. Let's have it right here. All right. Let me just uncomment this. Okay, so we are ready. And I don't need these all states right now because I have this machine in place. Okay, so now let's do some actions with our transitions. Okay, so like when we are loading this, we can instead do, okay, update form state. All right. And we do submit form. So now we go to a transition from one state to another. If everything is a success, we update the form state. All right, to form, or I think submit form success. So like we perform this action to go to the next state, or else if nothing turns out good and I cannot be logged in, I just do submit form error. All right, and based on this, while we have these transitions in place, let's update how we are rendering the UI, right? Okay, so how this is success comes is if the current state is equals is success, and if the current state that we have been tracking is states.is error, that means if we got the error and our state machine is in that error state, we just show that same message. And talking about our button to be disabled, I just say, okay, current state is states.is loading. And that's mostly it. And that's most of the refactors that you need, right? Let's just quickly refresh. And yeah. And let's quickly see if that turns out well. So maybe I enter a username or I enter a password. I try to log in. And yes, that works. Like, yeah, the error is like contrived, but like that, this part works. And that's the beauty of a React state machine, right? Because all of your logic is now at just a single place. And this is that only place that you want to go to when you are reading this code, right? And how awesome is that? All right. With that in mind, let's try to see what are the achievements that we got. So obviously now no Horcruxes, because now you have unified the soul of your app into just one piece and not just distributed. Obviously easy to debug because now you have a visualization in mind, and you can just now see that, okay, if my form is not behaving well, there is something that I have done wrong, or like something that I have not catered inside my state machine. So you know like where to look for as an error, like, or where to look for, rather than this whole code. And obviously no state explosions, because rather than three, you now have just a single state, and that is being orchestrated all by your state machine. Now, another thing that we already had as an issue were race conditions, where you are trying to do some asynchronous tasks and there are a number of them lined up and you don't know what the order can be. And that is the beauty of state machines and how they can help you, right? That at one point of time, your UI can just only be in one state and not in many parallel states. So if you have defined your state machines well, you won't be having an issue with the race conditions. So that is being handled gracefully. Another very important thing that I have felt is a designer to developer collaboration, because I feel that mostly all of the designers have a mental model of thinking in state machines. So the next time if you are going to be collaborating with your designers, you would know what to look for, or like what to ask them, and what is those number of conditions or like situations of a UI where you would need an input from a designer. So you know the state machines, you know the most possible ways your UI can behave, and that is how a designer is actually working. So like that makes the process more streamlined. And you also might be thinking that, hey, now I have this power of state machines, so let me just go in my code base and change everything with state machines. And I would like not recommend that. So I would like rather say that if there is a need for a state machine, that would mostly arise if your code or like if your component is very complex and like there's a need of being visualized in terms of its logic. And that is like mostly, and that is being like very well said by David Krushit in one of his tweets, that I really believe in what he mentioned, that if the UI is visualized and like that UI has a soul or a logic inside it that has to be visualized, then definitely we must go to the state machines, because our main motive is to make our code readable and maintainable, and like not to apply state machines on top of that. So yeah, I would say like just keep that part in mind to avoid like big days trying to like just update things to state machines. So just to mention as a side note, here are going to be the useful links that you might need. Here's a link to the code sandbox that I had been showing you in the demo, and also the link to the slides. So you can catch all those here. Last but not the least, I would like to mention is try this library called SetState if you would like to dive into this magic of state machines. This is a great library. I've tried it and I personally recommend it to all the folks who would like want to add state machines to their project. It really adds, so like it really just helps you add minimalistic code and like avoid all of those mumbo jumbos and boilerplates that we added in our demo. So try this out. I think you would like really love this. So kudos to David for this. So on a side note, again, we are hiring at Postman. So it would be like to be a part of our journey of building the product. Come say hi, and you can connect on us via our careers website. So that's all that I had for this presentation. So a big thanks to the React Advanced London, the people who had been involved in organizing this and making it a big success. So hats up to you guys. And last but not the least, you guys, the audience, thank you for having me. I loved having this chat and discussing things around. So see you guys next time. Signing off.